Welcome to another video in the Edge AI Masterclass. In this video, we will look at data normalization and see what it means, why is it necessary, and how we can effectively normalize our data. So, let's get started. First, let's talk about what data normalization is. Normalization is a pre-processing step in which the data is suitably modified to ensure it is consistent and scales appropriately across all inputs. This step helps avoid several issues, such as the NaN trap, where calculations result in undefined or not a number values. It also significantly aids in the convergence of models during training, offering faster training times and more accurate model performance. In short, it ensures that our machine learning model performs at its best. Now let's move on to see how to perform data normalization. The process can vary depending on the data that you have and the specific needs of your machine learning algorithm. Several techniques are used for data normalization. The first is scaling to a range. This method involves adjusting the scale of the data so that it fits within a specific range, typically 0 to 1 or -1 to 1. Taking our London temperature example again, this means converting the data, which would typically be between 2 degrees and 32 degrees, to values between 0 and 1, or -1 and 1. This method is particularly useful for algorithms that assume data is on a similar scale. The next one is clipping. This technique simply caps the values beyond a certain threshold. For instance, data points that exceed the 99th percentile can be set to the value of the 99th percentile, thus limiting the effect of outliers. In our London example, this could be setting the 45 degrees to 32 degrees. As we saw before, in general, clipping is more of an outlier removal technique than a data normalization technique. Another normalization technique is log scaling. This technique is usually used for data that has high variance. For example, house prices. In the US, house prices range from $200,000 up to $20 million. If you were to build a machine learning model using this data, using log scaling would be a good strategy. Finally, let's look at z-scaling, also known as standardization. This super popular technique involves rescaling the data to have a mean of 0 and a standard deviation of 1. This is crucial for algorithms that rely on the normal distribution of data, such as neural networks. And there you have it. In the next video, like before, we will see how to implement some of these techniques on real data. So see you there.